Hello. Today we want to look at self-referential structure. So far, we have seen how structure enables us to group different types of data under one name, right? What if we want our structure to be flexible? You know, unlike array, once an array is declared, it cannot increase or decrease at runtime. But what if we want our structure to connect to another structure of the same type? This is where self-referential structure comes in. Now I'm going to give you an example that will also explain linked list or other dynamic data structures, because after this project, my next project will be to teach you data structure and algorithm. So the example I'm going to give to you now will show you linked list, and which tells you that structure is actually the ancestor of linked list. So let's see how our structure can become dynamic, right? So that's what I'm going to teach you in this class. So let's write our normal code. So the first thing I will do now is I will say include stdio.h. By now you are familiar with this. And then I'll also include standard library because of our malloc.h. Now I am going to create my structure. I'll call it struct, and then I'll call it node. Now inside it, I will say int data. And then the next one, so this is my first member. So the next one will be what? Struct node, then the pointer. Next. So I will close this. So this is my blueprint for my structure. What I'm trying to do is, let's say a trained coach, right? So you have something like this, and then you have another one like this. So you have this here, you have this here. Now this is what? Data. Now this next will be this one, right? Then this is data. Then the next will be this one, right? If I want this trained coach to be connected to this one, so next time, instead of redesigning this blueprint, I can just add to my train. So a trained coach. So this is where you have people sitting. And then this is the anchor that is going to hook to the next one. So if this is what? 100, this place will be 100, meaning this one will point to this. I can increase it, I can add to this one, or I can reduce. That is the concept of self-referential structure. So that I've created the blueprint. Now, based on this blueprint, I'm going to create my variable for this structure. So I'll go to main. I'll say int main. Inside this, what I want a dynamic one. So I want to create that memory in the heap. So how will I access the memory in the heap? I will have to use what? A pointer. So I'm going to declare, since I want to create just two variables, so I'm going to create two pointers. So that would be struct node. Then I'll call the first one first. Then I'll call the second one second. So since the pointers are the same data type, so I'm just putting them in the same line. So the next thing I will do is I will create a dynamic memory in the heap, and then point this pointer to it, and another one point the second pointer to it. So first, because I'm going to use my malloc function, malloc function will return a void data type. So I have to typecast it to what? To this struct node. So struct node. I will call my malloc function malloc. gotten from this. Size of struct node, right? Then I will say second, I'll do same thing. Struct node is a pointer. I'll call my malloc size of struct node, right? So what have I done? I have created memories in the heap with what size? Size of struct node. What is the first one? Integer, then struct node. So whatever the size is what will be created in the heap. So, and I have this pointer, which is the first pointer pointing to it. Then I created another memory location, still in the heap. And then I have second pointing to it. So I have this. So that's what it means. So I have this memory. So let's say I have this as 100. I have this as 200. Then this place, since it's pointing to it, to be 200. Then I have my data. So that's what I have done. Now I'm going to assign value to this, my data. So how do I assign value to it? For this first variable that I've created here, I will say first, if I'm going to access these members of this struct using pointer, then I have to use my arrow. So first arrow data, I will assign 10 to it. Then first arrow next, which is this one, I will assign second to it, meaning I'm pointing it to this one. If I wanted it to stand alone, I will assign null to it. Then I will come here, second data, I will assign 20 to it. Then second next, I will assign null to it. So meaning it's not pointing to anything. That is the end. That is what I've just done. So what is it I want to do? So I'm going to create another pointer, which is the third pointer that I will use to move this. I will use that pointer, that third pointer. That will be here. So I will use it to switch. I will print out the value on the screen, then move this to this, and print out the value on the screen. That's what I'm going to use that pointer for. So I will declare it as struct node ptr. And then I want this pointer to point to this first one, which is pointing to this first one and then using it to move. So I want it to point to the first one. So it will point to what? First. So meaning this pointer, this third pointer now is pointing to first, pointing to the address of what? Address of first. And then based on that, I will move to this one. But to be able to do that movement, because if I have many structures, I will have to use this pointer to be moving to all of them. So what I'm doing now is, let's say I have the train. I have the train, the first coach of the train, second coach of the train, third coach of the train. And on each of them, there are doors. So I'm using this pointer to align to those doors so that people can come out. Then I move to the next one, people will come out. So what I want to say is, this pointer should keep moving until it encounter what? Null, meaning there is no more coach. So it will stop. So to do that, I'm going to use, since I don't know how many coaches, I can't use a for loop. I'm going to use what? A while loop. Okay. So instead of writing it here, because I don't know if you can still see, I'm going to move it to this place. So what I will do is I will come here. What should be here? What should be here? The while loop that should be here is what I want to write here. So following this line, I will say while, then I'm going to write my condition. While ptr not equals to null, right? Go in and do this and do printf inside bracket, I will do this percentage D. I want to put it this way, arrow, comma, PTR, data. I hope you can still see. PTR data. Then I'm going to change the value of PTR. PTR assign PTR next. Then I'm going to close this here. So I'll write return 0. Then I'm going to close my main, which is this one. I'll put it here. So that is my program. So what have I done? I created a structure. This is the blueprint. So for every manifestation, there's always a blueprint. And you cannot go outside of the content of that blueprint. If you try it, there will be an error. And that is what we call challenges. So this is the blueprint that I've created. Now, based on this blueprint, I'm going to create variables for this blueprint. But where will I store them? I'll store it in the heap. So I'm going to create a memory in the heap, dynamic memory in the heap. So I'm using my malloc function. So the first thing I did is what? To create pointers. Because the only way you can access a dynamic memory created by malloc is through pointers. So I created 2 pointers just for the sake of this class so that it will not be too long. I created 2 pointers, which are what? That will point to 2 different coaches. Then the first one is what? Telling the system, create this memory for me. It will create the memory that will be the size of what? This structure. That is a struct node. Then the second one too will create the same thing. You know, a self-referential point structure has a variable, a pointer that points to what? The self. Now, first data, I am now giving value to it. So the first one, which is this one, I'm giving value, accessing this data, 10. The second one is what? I'm pointing it to what? To the second, to this second. So I'm pointing it to it. Then that second, I have data 20 in it, and then it's pointing to what? Null. So what this is simply saying is like this. I have this coach, and I have this coach. So this one, this is what? 10. This one, this is what? 20. So this is what? Null. So why this one is pointing? So if the address of this one is 100, this place will be what? 100, meaning this is pointing to this, right? Now, if the address of this one is 50, just for the sake of the class, we are saying this. So this one is pointing to null, meaning that is the end. Why this one is pointing to 20? So this is the data. This is the data. So then I created another pointer. So that pointer is here. We call it PTR. And it's pointing to what? It's pointing to what? To first. So it's pointing to this one. So this will have 50 inside it. So it's pointing to this. Then I'm using my while loop to say if PTR is not equals to null, so meaning this place is not null, go in and print out the data. So PTR data, this one will print out 10, right? Using this symbol, it will have arrow like this. And then change PTR. So the value of PTR next is what? 100. So it moves to this place. It moves here. So PTR next becomes what? 100. Now, what is 100? Is saying go to this address and then print out the value inside it. So when it gets here, it will come in again and do PTR. PTR data will print out 20. Then it will do this. Then PTR next will come in here and it will give you what? Null. So now it's checking. PTR not equals to null. It's not true. It is now null. It will come out. So by then it has printed out 10, 20, and then this arrow like this on the screen. So you can see I can add more by just declaring another memory in the heap by just saying touch. Then I create this memory size and then I point to it. So I can keep adding to what? To the trained coach as much as I want, and then I can reduce it if I want to. So this is the concept to what? Linked list. So that tells you that structure is actually the ancestor of what? Linked list and other data structures. So what I want to show you is how you do self-referential structure, how a structure can point to a variable of its own type. So with this blueprint, you can see that a member of this structure is pointing to what? A variable of its type, which is this one. That's what I want to show you in this class. So let's go to code blocks. Let me demonstrate this for you to see. All right, so this is our code blocks on the self-referential structure. This is the program, but this time around, I actually added 3 pointers and then 3 memory locations. So I have 10, 20, 30. So this is it. I created my structure, which is what? The self-referential structure, pointing to itself. Then I created 3 pointers, created memory locations that will hold them. Then I assign values to what? To the first one, which is what? 10. Assign 10 to data. Then I'm connecting the second one to the first. And then I assign 20 to the value of that one. Then I connected the third one to the second. And then I assign 30 to the value of the third. Then I created another pointer, which I'm going to use to traverse them. So using my while loop, I'm now using the pointer and then changing the values of the pointer here. So let's run this. I actually added this in order to see the value of this structure. What is the size of this structure? So I added this in order to see it. So let's run this program for us to see what the output will be. Okay, so you can see I have 10, 20, 30. So the next one is null, so it ends. So you can see the output using this while loop. Let's make it this way. Our output is what? 10, then the arrow, 20, then the arrow, 30, and then, because it's not going to encounter the last one as what? Null. The next for the third one is null. That's why you're not seeing anything here. Then it came back to the next line to print out the size of the structure. So the size of the structure is what? 8 bytes. So that is what I want to show you in this class. So till we see in the next class, bye-bye.